Welcome back to the course Geology and Soil Mechanics. So, in the last few lectures we covered the shear strength of soil, and we have seen the different kinds of laboratory experiments as well as field test, and there are several issues related to shear strength of soil. Now, today we will be taking a few problems, few numerical problems on shear strength of soil, and which will give you some insight how to tackle the problem related to shear strength. Now, the first problem in this chapter, that is in shear strength, is here. So, the subsoil at a site consists of a 10-meter thick homogeneous layer of dense sand having the following properties: gamma d 16.2 kilonewton per meter cube, specific gravity Gs equal to 2.68 and phi equal to 35 degree. Okay. So, phi is nothing but the angle of internal friction of soil, and C is 0 here. So, because this is a dense sand kind of thing, so we can consider C is 0, right. The natural groundwater table lies at 2 meter below the ground surface. Assume that the soil is dry above water table. Okay. So, there is no such capillary rise and all those things we are considering. So, above the water table soil is completely dry. Determine the shear strength of the soil along a horizontal plane through the middle of the sand layer. And in the second part, if during monsoon the water table rises to the ground level, how will the shear strength along the same plane change? So, these two things we need to determine. Okay. So, first thing is that determine the shear strength of the soil along a horizontal plane through the middle of the sand layer. Okay. So, you have the sand deposit at the middle of the sand layer. So, if you consider any horizontal plane, so how the shear strength will be mobilized there. So, I mean, what will be the shear strength which will be mobilized at that particular horizontal plane. Okay. So, let's solve that problem. Problem 20. So, the horizontal plane under consideration is at a depth of 5 meter below the ground level, right. So, the horizontal plane on which you are going to find out or determine the shear strength, basically that plane is lying at 5 meter below the ground level. Okay. Now, we know from our earlier discussion that gamma d is equal to Gs gamma w divided by 1 plus E, where E is the void ratio, right. Or we can write 2.68, that is a specific gravity, this is your gamma w by 1 plus E is equal to 16.2 kilonewton per meter cube, that is given in the problem. Okay. Gamma d is given. So, from this I can get the value E is equal to 0.654, that is the void ratio is 0.654. So, once we know the void ratio of the soil, then we can find out gamma saturated, because these are the things we need. So, gamma saturated is given by, so these things are known to you from your earlier discussion into gamma w. So, if you put all the values, you will be getting gamma saturated is equal to 20.2 kilonewton per meter cube. Therefore, gamma submerged, so gamma prime, that is your gamma submerged, is nothing but 20.2 minus gamma W is nothing but 10.2 kilonewton per meter cube. So, we have got all the necessary parameters like your gamma saturated, gamma prime, that is gamma submerged, and gamma D, of course, it is given in the problem. Now, we are coming back to the first part of the problem. We need to find out the shear strength on the horizontal plane, which is lying at 5 meter below the ground level. Now, if I want to find out the shear strength, that means tau f, whatever you have seen in the discussion, right, tau f is nothing but C plus sigma tan phi. Now, what is C? C is the cohesion, that is 0 for this particular type of soil, that is dense sand, and what is phi? Phi is the angle of internal friction that is given in the problem, that is given as 35 degree. Now, what is the unknown parameter here? That is sigma. So, basically if you want to find out the shear strength on any plane, basically you need to know the magnitude of the normal stress acting on that particular plane, that is sigma. So, in this problem, so if you want to find out the shear strength along the horizontal plane, basically you should know the normal stress acting on that particular plane. So, what is the normal stress on that particular plane? That is nothing but the overburden pressure coming on that particular level. So, the normal stress on the given plane is nothing but sigma is equal to gamma D into Z1 plus gamma submerged into Z2, where Z1 is the depth which is lying above the water table and Z2 is the depth which is lying below the water table. So, above the water table, what is the unit weight? That is gamma D, and below the water table you have the unit weight as gamma submerged. So, gamma submerged I am writing as gamma prime, of course. So, I should not write, should not mix up with the notation. So, gamma prime Z2, right. So, if you put the values here, you will be getting 16.2. Now, what is the depth above the water table? That is 2 meter, plus what is the magnitude of gamma prime? That already you have got 10.2, and what is Z2? The depth below the water table is 3 meter. Now, because you are considering total 5 meter depth at which you are considering the horizontal plane, right. So, 2 meter plus 3 meter, total 5 meter. So, this gives me 63 kilonewton per meter square. Therefore, shear strength of the soil at this plane tau f is equal to C plus sigma tan phi. So, which is nothing but 0, C is 0, sigma already we have calculated, that is 63 tan 35 degree. So, which gives me tau f equal to 44.1 kilonewton per meter square. So, this is the shear strength at that horizontal plane which is lying 5 meter below the ground level. Okay? I hope that you have understood how to calculate the shear strength on a particular plane below the ground level. Now, in the second part, in this case the entire soil mass is submerged. So, if you see the second part of the problem, if during monsoon the water table rises to the ground level, how will the shear strength along the same plane change? That means, the water table rises to the ground level. So, the whole soil deposit is submerged now. So, in this case, the entire soil mass is submerged. Therefore, sigma, now I need to calculate only, so phi is not going to change, because that is a property, angle of internal friction of the soil, that is not going to change. Only variation you will be observing in the normal stress distribution, right. So, normal stress will be nothing but gamma submerged into Z. So, gamma submerged is 10.2 into 5, that is the whole depth up to the horizontal plane, and that is coming as 51 kilonewton per meter square, and tau f is equal to 51 tan 35 degree, which is equal to 35.7 kilonewton per meter square. Now, if you see this problem, so this problem I have taken for understanding the special thing, that when you had the water table at some depth below the ground level, you got the shear strength on a particular plane, that is the horizontal plane, as 44.1 kilonewton per meter square. Now, when the water table rises, okay, up to the ground level, so then you have got the shear strength on the same plane as 35.7. That means, reduction is happening due to the rise of the water table to the ground level, right. So, what I mean to say that if you want to design some structure, some geotechnical structure on a particular say soil deposit at some depth, say, so you need to calculate or need to consider the variation of the water table, otherwise you will be getting some misleading result. So, I mean, if you design the geotechnical structure based on the soil strength or the shear strength, now you need to consider the variation of the water table or the worst condition which is coming into the picture. That means, in this situation, the worst condition is when the water table is reaching or rising up to the ground level. So, that is giving you the worst shear strength. So, this is the shear strength which soil will give. Now, if you design something, okay, based on this shear strength, design some geotechnical structure, foundation or retaining wall or whatever. So, something you are designing based on this shear strength. Okay. Now, when the water table will rise during monsoon up to the ground level, then basically the soil is there to provide you this much of shear strength, right. So, but you have designed based on this, so you are gone basically. So, or if you on the other way, if you design the structure based on this critical or the worst condition, then basically whether the water table is coming down or whatever variation you will be getting, so that will not create any problem in the design. Okay. I hope that you have understood, that is why I have taken this problem to say this thing specifically. Now, we will take the second problem. The next problem says that 3 identical specimens of a partially saturated clay were subjected to an EU triaxial test and the following results were obtained. Determine the shear parameters of the soil. Now, basically this problem we are considering to talk about to determine the shear parameters, means shear strength parameters means that C and phi, that is cohesion and angle of internal friction. So, these two things are known as shear parameters or the shear strength parameters in soil mechanics. Now, this is the test we have performed, some EU test, and based on that we have got these results. So, what are the results? So, 3 samples we considered, sample 1, sample 2 and sample 3, and cell pressure we varied. For sample 1 it is 0.5 kg per centimeter square, for sample 2 it is 1 kg per centimeter square, and for sample 3 it is 1.5 kg per centimeter square. And the deviator stress you have applied till the failure, that is for sample 1 is 0.8 kg per centimeter square, for sample 2 it is found as 0.97 kg per centimeter square, and for sample 3 it is 1.13 kg per centimeter square. So, these are the things you have observed from the test. Now, you need to find out the shear strength parameters. Okay. Now, we know from our earlier discussion that sigma 1 is equal to sigma 3 tan square alpha plus 2 c tan alpha, right, where alpha is 45 plus 5 by 2. I hope that you recall this. This expression we derived from the Mohr circle, Mohr Coulomb failure criterion, when we considered at the time we have got this expression. So, sigma 1 is equal to sigma 3 tan square alpha plus 2 c tan alpha. So, that is valid for Mohr Coulomb failure criterion. Okay. So, now in case of the first sample, sigma 3 is equal to 0.5 kg per centimeter square and sigma 1 is equal to what? Sigma 1 will be how much? So, sigma 3 plus deviated stress, right. Sigma 3 is 0.5 and deviated stress is 0.8. So, you will be getting 0.5 plus 0.8, which is coming as 1.3 kg per centimeter square. So, this is your sigma 1. So, substituting in, so say this equation I am calling as equation 1. So, substituting this in equation 1, we get 0.5 tan square alpha plus 2 c tan alpha is equal to 1.3. Okay. Now, similarly, for the second and third samples, the following equations are obtained. That is, for second sample, this equation will be 2 c tan alpha is equal to 1.97, so equation 3, and for sample 3 you have got this is equal to 2.63. Okay. Now, subtracting two from 3, we obtain 0.5 tan square alpha is equal to 0.67. Okay. So, therefore, tan square alpha is equal to 1.34, which I can write tan square 45 plus 5 by 2 is equal to 1.34, and from which I get phi is equal to 8.4 degree. Okay. Now, substituting for phi in equation 2, okay, we get 0.5 into 1.34 plus twice C multiplied by tan alpha. So, tan square alpha is 1.34. So, tan alpha will be 1.157 is equal to 1.3. So, from this I get C equal to 0.27 kg per centimeter square. Okay. So, we have got the shear strength parameters. So, basically if you see this problem, we have used equation 2 and equation 3 for all the times, but you have to check this thing with equation 4, that whether these parameters is satisfying equation 4 or not. Equation 4 is given there. So, in this equation you have to put the values of C and phi, and then you have to see that whether equation 4 is getting satisfied or not, right. So, that we will check. So, for check, substituting the values of C and phi in equation 4, we get LHS left hand side is equal to 1.5 into 1.34 plus 2 C tan alpha 1.157 is equal to 2.63 is equal to right hand side of equation 4. So, it is getting satisfied. So, that means the shear strength parameters for this problem is C equal to 0.27 kg per centimeter square and phi is equal to 8.4 degree. Okay. So, you have got the shear strength parameters for this problem. Okay. I hope that you have understood that how we have used the equation, basic equation of this Mohr Coulomb failure criteria, and based on that we have got the shear strength parameters, and these observations basically you are getting from the laboratory experiment. So, if you perform any kind of any on any sample or any say particular soil deposits of identical 3 samples say you are considering, and then with the variation of shell pressure, okay, you are doing the U test, and from this test you can find out the shear strength parameter C and phi, right. Okay. Thank you very much. So, I will take the next problem in the next class. So, I hope that you have understood these 2 problems whatever we have solved just now. Okay. So, which will give you some insight how we can use the laboratory experiment to find out the shear strength of the soil, and also we have seen that with the variation of the water table how the shear strength varies on a particular plane. So, in the next class we will take few more problems. Thank you very much.